And welcome to this tutorial on sUAS facts and myths. Bill Schwahn will be joining us here in a moment, but first, a few announcements. If you have any questions about today's topic, or if you need to contact us, please feel free to reach out to the Infrared Training Center directly. You can call us at 1-866-872-4647 or via email at info@infraredtraining.com. The Infrared Training Center website is where you'll find additional free tutorials, as well as our complete global training schedule for certification classes. This includes ASMT-based levels 1, 2, and 3, as well as an ISO-based Category 1 course that's now available. Head to infraredtraining.com to learn more. While you're online, be sure to get social with the Infrared Training Center. Follow us on X, Facebook, Instagram, and LinkedIn, where you'll find helpful tips, thermal imaging best practices, and much more. Be sure to also check out Thermography Talk, now available on Apple Podcasts, where we feature these tutorials so you can learn while on the go. The Infrared Training Center also runs a number of special training offers throughout the year. So if you're looking to get certified, there's never been a better time. To learn more about these, please feel free to give us a call, send us an email, or visit the Infrared Training Center online at infraredtraining.com. So with that, let's bring in Bill Schwahn. Bill's a Level 3 Master Thermographer with the Infrared Training Center and an FAA Part 107 certified remote pilot. Today he's going to talk about some of the more common myths that we hear regarding sUAS operations with thermal imaging. Hey Bill, great to see you. How you been?
Hey Matt, I'm doing great, thank you.
Well, thanks for being on for today's topic. I was interested in this. This sounds definitely different, something we want to talk about. We haven't done a lot on this for webinars, but sUAS thermography facts and myths. That's an intriguing title that you've come up with. What inspired you to discuss this particular topic here today?
Well, Matt, we've been getting a lot of questions from students and just the general pilots out there, sUAS pilots. And a lot of those questions have to do around thermography, like what am I looking at? Can I measure things? So a lot of these are the inspiration came from the students and the emails and the phone calls. And can I do this or can I not do this with an infrared camera from the air?
Nice. And how about the presentation today? I know you've got an outline here on what we're going to be covering with in terms of myths and whatnot. Let's give everybody a little taste of what's coming up here in the presentation.
So today we're just going to take a look at, hey, can I measure from an sUAS with an infrared camera? What is radiometry? And why is temperature measurement more challenging from the air than maybe with a handheld camera? What's the differences between handheld cameras and sUAS thermography cameras, infrared cameras? How about the field of view? How do I know what I'm looking at the ground from different angles or from different AGLs to the object of interest? So, and understanding the software is important too. So I've done some research here and came up with a few questions that are pretty common when I get the phone calls during the week or during the class. So I thought we'd address some questions here, Matt.
Well, let's get right into it, Bill. I've got the first one here, the myth. sUAS cameras are autofocus, so there's nothing that you can do as an operator to actually improve or, I guess, control the focus when you're flying.
Matt, this is one that we get quite a bit. Actually, the sUAS pilot is in control, as we all know. So there's several things we can do. One, we can fly too fast. We can yaw too aggressively, and our distance to the objective is too great. So we have to be conscious of this when we're collecting data. We're not just flying the aircraft, we're actually collecting data. So being aware that we need to be at least 30 meters or less to the object of interest for the camera to focus correctly. Understanding our humidity levels. High humidity will cause the image to look foggy, blurry, has nothing to do with focus, has to do with humidity. So these are some things that we can do that we can, as pilots, to get a better focused image for us and our clients for analysis.
How about this next one, Bill? That the temperature ranges in an sUAS camera are automatically determined, so it's something that the operator can't adjust. Is that true or false? What's up with that?
Well, Matt, in an sUAS thermography camera, you can't measure every temperature available. So in sUAS thermography cameras, we call it gain. So in your controllers, you're going to find something that is called gain. That is a range in a handheld camera. It's called the range. So what is the range? The range is the highest and lowest temperatures that the camera can accurately read. But there's one more caveat when it comes to sUAS infrared cameras. If we're in high gain, that means that's going to be a smaller range. And remember, all of your ranges will change dependent upon manufacturer. If we're in low gain, we're going to have a higher range of temperatures that we can evaluate. But the caveat is this. In high gain, our margin of error is plus or minus 5%. In low gain, our margin of error increases dramatically to plus or minus 20% or 20 degrees Celsius, whichever is larger. So we want to try to find the gain in our respective software in our controller and try to operate in high gain as much as possible.
I saw you had an example here. This is on the next slide of what it looks like something that's out of range or out of gain. Is that what we're seeing?
Yes, in that in an sUAS camera, because the software that operates the aircraft is not radiometric, it will not give you an indicator that you are out of gain. You can only get that indicator if you have a radiometric image and you put it in radiometric software. So what does radiometric mean? Radiometry analyzes the individual pixel and identifies the temperature. So radiometry with a regular infrared camera captures two things: good resolution, and it also captures, each pixel captures a temperature. So range can only be determined, out of range can only be determined in radiometric software.
All right, Bill, so the next one I have here is about thermal tuning, is adjusting the level and span. That can be performed in the sUAS manufacturing software that controls the flight of the aircraft. I guess, can you have control over span and level adjustments in the actual flight controller?
Actually, you do not, Matt. And the reason that you do not is because, again, the controller, the software in the controller that controls the flight of your aircraft is not radiometric. So you're going to see features in that controller like region of interest, daylight, different types of settings that change what you see on the screen, but does not accurately change contrast and brightness in the radiometric image. So two images you see on the screen here are of the same field of view. The top image is bright in color. So by adjusting contrast and brightness or level and span properly in radiometric software, we can actually identify the issue in this image, on the bottom image in the screen. And that issue is the insulator is hot, and it should not be, and it's very hard to see in the image that the camera took.
So how about this one, Bill? When it comes to measurement accuracy, we talk about how accuracy can fluctuate by plus or minus 2% or 2 degrees Celsius, depending on the measured value. Is that true or false when it comes to operations with aerial infrared thermography?
Well, really, with an sUAS thermal camera, this is typically not a correct statement. And we get this one quite a bit, Matt. We'll see all kinds of comments, plus or minus 2% or 2C, plus or minus 5% or 5C. Sometimes in manufacturers' owner's manuals, that statement will happen. Here's the real challenge. The challenge is that all sUAS thermal cameras are not ambient temperature compensated. What does that mean? That means that the camera can't adjust to the temperature of the environment that it's working in. So the internals of the camera can't perform adequate adjustments for accuracy. So I recommend that you may not want to state a margin of error, because it's very, very hard to determine with an sUAS thermal infrared camera.
For the next one, Bill, I know the topic of resolution comes up very often in training classes. This one regarding the field of view, that someone is unable to determine the size of the field of view or how much area that they can see at a given distance.
Well, I think, first of all, Matt, that's a great question, and one we get quite a bit. I think we have to realize that the RGB or visible camera field of view will be different than the infrared camera field of view. So this is going to be dependent. You want to research this in your owner's manual. What is the instantaneous field of view, IFOV? It's usually designated in milliradians. Small m, RAD, milliradians. So it becomes fairly easy to determine what that will be. Many of you have maybe known this as ground sampling distance. One way you can do it in an infrared camera is to determine the IFOV, or how much I will see on the ground. You take the instantaneous field of view in milliradians times the distance in meters. Really easy to determine. And of course, you would take that times the number of pixels in your camera. And most cameras are going to have pixels that are going to be 640 by 512 today. So it becomes really easy to determine that. The difference between RGB or infrared cameras is that infrared sUAS cameras will have 4 primary lenses. 9mm lens, which is considered to be wide angle for flat roof, solar, and agriculture. 13mm lens is considered to be a mixture of telephoto and wide angle for flat roofs, solar panels, buildings. A 19mm lens is considered to be telephoto in an sUAS infrared camera. Really good for overhead power, electrical distribution. And a 25mm lens is very telephoto for overhead electrical transmission lines. Notice that a 9mm lens is going to have a wide field of view, and a 25mm lens will have a very narrow field of view. So you have to choose the camera that is right for the majority of your applications, and understanding that before your camera purchase or before your application, you fly your mission, is very, very important.
So Bill, while we're on the topic of temperature measurement here, how does the operator know that perhaps they're close enough to have sufficient resolution to get an accurate temperature measurement?
Matt, that's a great question. This is a question we get quite a bit, and that's called the measurement field of view. Now, the measurement field of view, for example, in most handheld cameras, is going to be approximately, and I say approximate because this depends on a lot of factors, 4 pixels by 4 pixels. However, the measurement field of view in an sUAS infrared camera is approximately 10 pixels by 10 pixels. So we need 2.5 times more pixels to measure something accurately from the air. So in the level 1 sUAS class, we actually have charts that will show you the distance you need to be to the object you're going to image and measure based on the camera and detector size. And that allows you to ensure that you're going to get some accuracy in temperatures. Otherwise, if I just put a spot tool on it, I have no protocol that I'm following that actually says, hey, I followed a measurement field of view standard, and this is why I believe the temperature to be accurate.
So how about this one when it comes to temperature measurements with sUAS? The myth here being that I can apply a measurement tool on my controller during flight, and then that temperature will be correct. Is that a myth?
It really is a myth. The fact is that when you place a measurement tool, whether it be a spot or a box on the controller that operates your aircraft, remember that that software is not radiometric. So the temperature that you get could be very, very wildly off. And why is that? That is because, again, the software that operates your aircraft is not radiometric. In order to get accuracy in temperature, you'd have to follow set procedures that we talk about in the Level 1 sUAS thermography course in order to get accuracy in measurement, including measuring reflected apparent temperature, making sure the emissivity is correct. Even though those might be in your controller, they cannot impact the temperature measurement unless it's in radiometric software. So one of the questions we get, what do you mean? I have a radiometric camera. What do you mean the temperature's not right? Your camera's doing the job. It's a radiometric camera. It's capturing all the information correctly. Now we need to complete that by using a radiometric software to interpret that data and give you accuracy. So you might consider using FLIR Thermal Studio to interpret that, or a radiometric software to interpret your data for accuracy.
So Bill, as we wrap up here, I've got a couple questions that I think are some of the more common ones that we receive from students or prospective students that are looking to get training. The first one of which is, what are the differences that are seen between handheld thermal imagers and those that are used for sUAS? I guess what are the primary differences or considerations that we're looking at in terms of temperature measurement accuracy, all of that, and what would we tell students that?
Well, that's a question we get quite a bit, Matt. And it's important to remember that an sUAS infrared camera is not ambient temperature compensated, so it won't be as accurate as a handheld camera. We have more challenges collecting the data from the air, greater distances, more wind speed typically, more ambient conditions. By the way, sUAS infrared cameras cannot adjust for atmospheric attenuation, distance, and humidity. So even though we collect a great image and we put it in the radiometric software, the cameras today do not collect those variables for increased accuracy. So there are a few challenges and differences. Safety is another one. We talk about safety. When we're collecting data from an sUAS, we could be 30 to 40 meters away from the object, and we have to watch for wind speed, guy wires, make sure our altitude is correct, make sure the camera position is correct. There's a lot more variables with sUAS cameras than with handhelds.
And then another question we get here, and this is from those that maybe have gone to level 1 and gotten their certification for level 1 thermography. How is that certification different from the one that we offer with the level 1 sUAS course? What are the differences between those classes, the big differences?
Well, the level 1 thermography certification is a great certification. However, it's primarily related to handheld cameras. In the level 1 sUAS course, we dive into the differences between field of view, measurement field of view, the instantaneous field of view, the available lenses, how to fly the mission correctly to get good data. Well, we all like to fly. When we are flying a mission to collect data, we have to ensure that that data is as accurate as possible. So we have to take the time in mission planning to make sure we have the right camera, the right AGL to the target of interest, and we're able to actually acquire the data for further evaluation.
All right, Bill, thank you. That's perfect. Appreciate it. Thank you very much for your time today. Very interesting topic here, the myths and facts of sUAS thermography. I hope to do this with you again pretty soon.
I look forward to it. If anybody wishes to contact me at william.schwann@teledyne.com. Thank you and safe flying.
Remember, if you have any questions on today's topic, please feel free to reach out to the Infrared Training Center directly. Calls at 1-866-872-4647 or reach us via email at info@infraredtraining.com. Our website is where you'll also find other free tutorials on a variety of topics and our complete training schedule. Plus, we also run a number of special training offers throughout the year. To learn more, give us a call or visit the Infrared Training Center online at infraredtraining.com. Thanks again for watching, and we'll see you online again soon.